Welcome to Maths and Science by IITIAN channel. In this lecture, I will be solving a very useful problem involving beta gamma functions, calculus, and also reflection formula of gamma, which is gamma z into gamma 1 minus z is equal to pi by sin pi z. This is very useful identity as far as gamma function is concerned, which I have explained in my previous classes, previous lectures on. It is gamma reflection formula. I have already explained in my previous lectures when I have dealt with beta gamma functions. And we will be using this reflection formula and definitions of beta gamma function, and also taking advantage of beta mn is equal to gamma m into gamma n. This also I have derived also in my previous classes. Please refer to them, please see them and try to understand them. Gamma m plus n. Now, here we have to find out the integral minus infinity to plus infinity 1 by 1 plus x to the power of 64 dx. It's a very good example. Please pay attention till the end. If you like this video, if there is a value addition to you because of this video, kindly hype this video, share this video and subscribe to my channel. Let's move forward. What is the question? Question given is find the value of minus infinity to plus infinity 1 by 1 plus x to the power of 64 dx is equal to how much? This value we have to find out. And from the definitions of beta and gamma functions, we will solve it one by one. Please follow. Beta mn is equal to 0 to infinity t to the power of m minus 1 divided by 1 plus t to the power of m plus n dt. It's a standard formula. It's a standard formula for beta. Here, what we have to find out is integral minus infinity to plus infinity 1 by 1 plus x to the power of 64 dx. Because it is an even integrand, it can be written as I is equal to integral minus infinity to plus infinity 1 by 1 plus x to the power of 4 dx is equal to integral 0 to infinity 2 into 1 by 1 plus x to the power of 64 dx. That means the given integrand I is 2 into 1 by 1 plus x to the power of 64 dx. The limits will be from 0 to infinity instead of minus infinity to plus infinity. Compare this with beta mn, which is integral 0 to infinity t to the power of m minus 1 whole divided by 1 plus t to the power of m plus n dt. Don't worry about dx and dt. Now, here, let us go for this. This is in the form 0 to infinity dx by 1 plus x to the power of n. Let us try to apply our algebra and calculus. Let t is equal to x to the power of n. This t is different. Don't get confused with that t. This is only for the sake of your convenience I have written this. It can be 0 to infinity y to the power of m minus 1. You can even say, if you want, instead we will remove the t here, so that you should not get confused with this t, and this is for definition. This is for definition purpose. 1 plus p, let me say, p to the power of m minus 1. Variable, some variable. Okay. Don't worry about the letters. Apply the procedure. Let t is equal to x to the power of n in this. What happens? It implies dt is equal to n into x to the power of n minus 1 into dx. Do you agree? 1 plus x to the power of n is equal to 1 plus t. And dx is equal to 1 by n into x to the power of n minus 1. Dx is equal to 1 by n into 1 by x to the power of n minus 1 into dt. Do you agree? From this, dx is equal to 1 by n into, what is x to the power of n minus 1? X to the power of n is equal to t. X is equal to t to the power of 1 by n. That means 1 by t to the power of 1 by n into n minus 1. Do you agree? That is equal to into dt. That is 1 by n into, what is the dx value? 1 by n into 1 by t to the power of 1 minus 1 by n. Do you agree? Into dt. Dx is equal to 1 by n into t to the power of 1 by n minus 1. Do you agree? Dt. You replace dx here, then integral 0 to infinity dx by 1 plus x to the power of n is equal to, because we are interested in finding 1 plus x to the power of 64. Let it be an arbitrary, let us solve for it. So that 64, 128, whatever value you want to put, you can put. Because we have reduced I to this one. Now we are interested in this. We are interested in this. Now this will become 0 to infinity. Dx is 1 by n t to the power of 1 by n minus 1 into dt divided by x to the power of n is 1, t, 1 plus t. This becomes 1 by n into integral 0 to infinity t to the power of 1 by n minus 1 whole divided by 1 plus t dt. Just compare this with beta mn. But beta mn is equal to integral 0 to infinity t to the power of, not t, rather we called it as p, because to avoid the confusion, p to the power of m minus 1 by 1 plus p to the power of m plus 1, m plus n. Not t, it is p. Again we are making same mistake, m plus 1 dp. Here it should be dp, not dt. When we have taken the variable as p, it should be dp. Now, you compare 1 plus t, 1 plus p. To the power of 1 here, that means from these two, if you put m plus n is equal to 1, and m minus 1 is equal to 1 by n minus 1. Then what happens? This becomes 0 to infinity dx by 1 plus x to the power of n is equal to 1 by n into 0 to infinity t to the power of 1 by n minus 1 whole divided by 1 plus t dt is going to become 1 by n, it will be as it is, this value, this value, this whole value will become because ultimately beta m plus beta n should be 1. Beta in m value we will be writing 1 by n, and in n value we will be writing 1 by 1 minus n. If you have any confusion, please comment in the comments column, I will reply. Are you able to follow? From this, you get 1 minus m is equal to 1 minus 1 by n. This is what we have got. And these two added together, this we can even write it as, to avoid the confusion, be m dash n dash. P to the power of m dash n dash, because lot of m dash. M dash n dash should be 1, m dash plus n dash. M dash minus 1 is equal to 1 by n minus 1. 1 minus m dash is equal to 1 minus 1 by n. And n dash is equal to 1 minus m dash. This is n dash. When it is n dash, this is m. Because m dash plus n dash should be 1. Are you able to follow? So, integral 0 to infinity dx by 1 plus x to the power of n dx, sorry, already dx is there, is equal to 1 by n into beta 1 by n 1 minus 1 by n. This is the standard formula, please remember it. The above was the derivation for the standard formula. Now, we have another standard formula. Beta mn is equal to gamma m into gamma n divided by gamma m plus n. This is also very, very important formula, please remember. Very useful formula. These whatever formulas we are deriving, they are very useful in calculus and beta gamma functions. Now you just see. Beta 1 by n and beta 1 minus 1 by n. When you add those two, the value is 1. When you add these two, the value is equal to 1. Hence, beta 1 by n 1 minus 1 by n is equal to gamma 1 by n gamma 1 minus 1 by n whole divided by gamma 1 by n plus 1 minus 1 by n. That implies beta 1 by n 1 minus 1 by n is equal to gamma 1 by n into gamma 1 minus 1 by n whole divided by gamma 1. What is the value of gamma 1? Gamma 1 is equal to 1. Please remember this also. Gamma 1 is equal to 1. Now, by applying all these, we will get the answer for beta. Beta 1 by n, beta 1 minus 1 by n is equal to gamma 1 by n into gamma 1 minus 1 by n. This is very important derivation, very useful for engineering and calculus. Now, this gamma z into gamma 1 minus z is equal to, this is the reflection formula. Which I have derived already, pi by sin pi z. This is reflection formula, very important formula. This is gamma reflection formula. Now, what will be the value of gamma 1 by n into gamma 1 minus 1 by n? Here z is equal to 1 by n. Put z is equal to 1 by n. What happens? Pi by sin pi into 1 by n. Do you agree? Hence, ultimately we have to find out the value of this one. Therefore, by substituting this value, integral 0 to infinity 1 by 1 plus x to the power of n dx is equal to 1 by n into beta 1 by n 1 minus 1 by n is equal to 1 by n into gamma 1 by n into gamma 1 minus 1 by n. Hence, its value becomes 1 by n into, what is the reflection value? This is the reflection formula. For the reflection formula, what is the value? Pi by sin pi by n. Pi divided by sin pi by n, which implies this is equal to 1 by n into cosecant pi by n. Pi by n into pi. That is equal to pi by n into cosecant pi by n. 1 by sin is cosecant. 1 by sin theta is equal to cosecant theta. Please remember trigonometry. This is a trigonometrical identity. But what we are supposed to find? Integral minus infinity to plus infinity 1 by 1 plus x to the power of n dx is equal to 2 into integral 0 to infinity 1 by 1 plus x to the power of n dx, that is equal to 2 into pi by n into cosecant pi by n. That implies the final answer for the question integral minus infinity to plus infinity 1 by 1 plus x to the power of 64 is equal to 2 into integral 0 to infinity 1 by 1 plus x to the power of 64 dx, that is equal to 2 into pi by 64 into cosecant pi by 64. That implies the answer to the question is minus infinity to plus infinity 1 by 1 plus x to the power of 64 dx is equal to pi by 32 into cosecant pi by 64. This value is approximately equal to 2.00. Some 8 is there after 3 zeros. You can neglect that if you are not asked to do exact calculation. This much answer is correct. This is how, by using the beta gamma functions, their properties, and integral from minus infinity to plus infinity 1 by 1 plus x to the power of 64 dx is calculated, and instead of 64, if it is n also, we have calculated the formula. We have used the beta function definition, we have used the gamma function definition, and we have used the reflection formula properties, and we got the value. With this, I wanted to conclude this lecture. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. If there is a value addition because of this lecture to you, kindly hype this lecture, kindly share this lecture, and subscribe to my channel Maths and Science by IITIAN. Best of luck to everybody. Thank you.